So for the past month, I was attempting to make a different type of precipitate for at least the purification part, or the isolation part, not the purification, the isolation part of an extraction of indoles. And at first, since my quick AI chatbot searches showed at least some promise that a bisulfite adduct could be formed with an indole, I had some hope that it would work, and I attempted it on a mimosa root bark extract as well as some yopo seed extract. With the yopo seed, it formed a pretty fatty, oily bisulfite. I'm not sure if I was able to capture it, but after the yellowish precipitate formed, when I kept it drying in the air, exposure to the air, it formed a gelatin-like goo, and then I dissolved it in water and alkalinized it, and there is a precipitate you can see here from the yopo extract from the bisulfite portion. And I need to make more L-rich reagent, but this one does seem to have isolated the indole, at least in theory. However, the other portion, the DMT portion, unless I'm fairly mistaken, it did not precipitate with the bisulfite adduct formation. I isolated the bisulfite that formed, and then I alkalinized it to break the adduct to form the free base. I did a traditional hexane extraction, and there was an extremely minimal amount of the indole that I wanted, and that would just be the small amounts that sometimes pass over. And in theory, it should all still be in this solution. This solution is extremely clear. It was already filtered from the bisulfite precipitate that formed, and in theory, all of the indole should be here. I'm gonna let this evaporate completely, and then I'll try to work it out. And this, I tried to get a precipitate to form with the bufaltine. Since it's water insoluble, I thought that it would precipitate out. It didn't. With excess amount of an acid or an alkaline agent, the bufaltine will redissolve. So after freebasing it, I added some acid to make it a pH around 7.8 pH, but it did not precipitate. I left it in the fridge. Nothing fell out. You could see just a cloudy solution. Afterwards, I added a salt brine, and again, nothing precipitated out. You can just see the milky solution. So my comments on this is it did not work at all. With the bufaltine, there's a small possibility that I did isolate it, but if not, it's all here, a mixture of the two indoles are in the solution, which I'll allow to evaporate out. So this I'll test later with my L-rich reagent to see if there's the indole reaction. On the specific precipitate that formed, the bisulfite precipitate, I did use the L-rich reagent on it. However, from searching, the bisulfite would interfere with the indole reaction. So regardless, that test did not work out for this, and in the end I just wasted a whole bunch of solvent attempting this. But I guess it's partly my fault. I did read that this is mostly for separating ketones and aldehydes. Yeah, I think that's right. And the indole that I found that does form a bisulfite adduct is an indole anhydride. So I guess it's my fault really on attempting it. But regardless, like I mentioned, I do enjoy the process of testing and seeing if my ideas actually work. And this is the Phalaris grass extract. With my DIY TLC plates, the issue I have is the detection rate. Even with the UV light, the detection rate is fairly high. With commercial grade TLC plates, many members on the Phalaris thread and on the Nexium thread, they can detect as low as 0.01 milligrams per milliliter of the indole. But with my TLC plates, I need to be closer to 1 milligram per milliliter. Again, since I only do a tiny spot, it's far under 1 milligram for the TLC, but it simply does not show up. This is the concentrated extract of 4 grams of dried Phalaris grasses. So this should be concentrated enough. I'll be concentrating even further just to test if it shows up with my DIY TLC plates. Since I'm not going to be able to do quantitative amounts with my TLC plates, it's not a huge issue. What I'll be doing in the future is a very quick hexane extraction, since I'll be using a larger volume rather than doing just say 30 milligrams of plant material. I'll use a few grams, do a mini extraction using hexane, and then I'll salt it with vinegar, and I'll do the TLC spotting with the vinegar, and hopefully I get something to work out. A big shout out to all of my supporters, since every small amount helps. I will need to purchase some new solvent in the future for my experiments again. And most recently, I think I showed it, I had a new LED panel that I imported from China. And the latest supporter, Benito, his support helped cover the cost of the LED light. So I'm pretty excited. I do enjoy the TLC work. It's not as usable as using commercial plates, but it's very cheap, and I can keep just doing multiple experiments. And it did work with a Psychotria verdis leaf sample that I made, since that's concentrated enough. The DMT spotting with the 275 wavelength, it worked out. Hopefully it'll work out with this Phalaris for the 5 meo DMT spotting. And yeah, I also originally attempted using ammonia oxide to remove a majority of this chlorophyll, but it did not work. Obviously you can still see a very dark green extract here, but with the ammonia oxide that I made with that plunger style filter that I made, it does remove one of the chlorophylls, I believe chlorophyll B. I could be wrong. It could be A, B, C, whatever other chlorophylls there are. But it does remove one of them. But the other is so heavy and saturated that it doesn't remove enough to make it worthwhile. So I'll be skipping that in the future. And besides the silica plates, I want to attempt an aluminum oxide TLC plate to see if it does any better job at detection with my DIY nature of this. So yeah, thanks everyone for watching. This was mostly just a fail video on the bisulfite attempt to make a precipitate to isolate the indoles. I'll do an update in the future when I get around to testing the Yopo extract portion. There is a possibility that it is isolated with the bisulfite, but it does need testing. With the DMT, it does not precipitate at all, or just a minimal amount, mainly by forcing co-precipitation. Basically, the DMT is the contaminant of the bisulfate that formed, and in theory it should all be here. But again, I have poor starting material since I can only find the outer root bark, and I just work with what I have.